Good afternoon. Myself, Sambasam, Assistant Professor at SNS College of Technology in the Department of Mechatronics Engineering. I would like to welcome for the another session in the Introduction to Robotics in the Unit 4 of Industrial Robot and Applications. This video is continuity of the previous video, which is nothing but the different cell layouts and how the cell layouts makes an impact in the robot cycle and time analysis, and how the production it has increased in the production rate, and how it has been economically useful for the industrial applications. So this is in the previous session we have discussed about the work-centered layout, but in this topic we are going to discuss about inline robot workflow. So as I said, the picture shows it is nothing but an assembly robot. In work center robot, there is only one robot which works or performs based upon the necessary requirements from one cell to another. From one machining to another machining, where it is get the raw materials and it releases everything in material. And this is how the inline robot, centered work cell layout has been done. But in inline robot work cell, it is nothing but it is like an assembly sector. As I said earlier. It is one of the key factors where the large number of working has been done through different robots, and the different robots perform different operations. That is the word thing there. So more than one robot are kept near the conveyor along with, or we can say then along with the conveyor, where to decide to perform several tasks. Each robot or performance in a separate operation which results in an end product. Instead of one robot doing everything, the multiple robots to a multiple tasks which results in an end product, which is like a car manufacturing industry. So as in the picture shows, there is a two robot where the conveyor has been done, the work part and the conveyor is there. The work part is continuously moving from one part to another part within specific period of time. Once the specific period of time has been carried out, the robot can do the perform task when the material has stopped to near to them, which results in an machining that product, and sometimes it will results in an outcome of the product. So it has to like perform like an welding line. So this depends upon the three different types of transport systems, especially intermediate transfer systems, continuous transfer systems, non-synchronous transfer systems. So what do you mean by intermediate transfers? This is the first question we will address that. Because there is a differentiation in continuous and non-synchronous. So intermediate, it is nothing but it is like a start and stop motion. It is like a bus path where there is a lot of spaces has been created there, where once the intermediate transfer line has been taken, it takes place from one place to another place where the start and stop motion has been carried out. Once the stop and stop motion has been carried out from one point to another point, they continuously transfer the part from one portion to another portion, from one machining part to another machining. It is like car assembly where the welding has been done, then the painting coating has been done, then the fixation has been done, then the engine fixation has been done, and finally the outer layout has been come out. This is the advantage of these parts are registered in a fixed location and the orientation with respect to robot during the work cycle. The example shown for them is given. And the next one is continuous transfer. It moves along a constant speed direction, and the position of the orientation of the parts are with respect to the line changing. So it does not require tracking problem. It does not require a sequence order, but there is an issue like a tracking problems, that the relative position orientation with respect to tool and workpiece may changes according to the motion of the controller. So similarly, the robot works the moving baseline tracking system by moving the robot parallel to the conveyor at the same speed, or by stationary baseline tracking the system. That is nothing but a tool maintenance position has to be controlled over the sequence of time. So this is example where the conveyor is moving running spot. The robot works on the moving conveyor with a specific number constant time. And non-synchronous transfer systems, it is similar to a stop and go manner, but in this process therein each work part are independent to another parts. So continuous instead of continuous transfer, if there are several tasks, they can move from one place to another place, which results in a particular motion of the particles, where the parts are being processed and inline, and each is operated independently. And these can be obtained by using sensors, where whether the product is right or wrong, it can be achieved by using sensors. So the more complex structures can be obtained through this process, and finally the process So these type of working transfers are important in industries as like mobile robots, as like an intermediate transfers. The inline robots are important thing which where the industry makes a major growth in 4.0. For mobile worksite layout, we will discuss in the next video. Let's see, and up to that, thank you for watching this video.